Hello, my name is Evan Jean Blanc. I am a first-year master's student at Iowa State University studying architecture. The project you see here is a complex adaptive system of smart growing modules. This module within urban space is meant to increase access to fresh, nutrient-dense forms of food. It can also help to spur emergent systems of informal economies that utilize peer-to-peer networks to transfer fresh foods among users. Analysis of the existing Western conditions shows that many growers, suppliers, and distributors utilize large amounts of resources and time to transfer goods directly to consumers. This can largely be contributed to a lack of growing space as well as local agricultural knowledge among users. A relevant case study conducted in South Africa showed that many users benefited from, if not relied on, local peer-to-peer networks of food production and distribution. Reliance on local markets rather than large-scale suppliers and distributors made sure that local food needs were always met among residents. Attempting to learn from both of these contexts, an emergent dynamics model using the module to increase grow space at the individual resident level is developed. This increased access to grow space in turn prompts peer-to-peer networks of food production and distribution. This reliance on peer-to-peer networks of food production decreases the reliance on large-scale suppliers and producers. The module proposed monitors a series of variables in relation to the plant's health and well-being. Solar radiation, GPS location, weight, and water content of the soil are all monitored. 3 different various scales and sizes are offered in relation to the plant's size intended. Users can also alter the size of the modules based on the growing space required and allowed. Through the monitoring of these variables, information over time can be pooled to help develop premier growing conditions and locations for plants within an area. With the aid of a mobile interface, users are able to track the progress of their garden and individual plants at any time. Access to local agricultural knowledge, as well as market locators, allow for distribution networks to be developed. Individual plant productivity can be monitored over time, and services can be scheduled among peers, making the care of a garden a choice rather than a chore. Various sizes of the module application make it so that individual users can tailor the size of their garden to their individual needs. A small-scale bike cart or a medium-sized trailer garden offer users the opportunity to flex their green thumbs. A large-scale personal garden can fill up an individual's backyard, and entire cities can even monitor the health and progress of their plants over time at a city scale. By crowdsourcing plant productivity data in relation to local microclimates, plant productivity as a whole can be increased among communities who use this module. Local agricultural and growing practices are also shared via the message boards of the mobile interface. This increased access to knowledge can also increase plant productivity at a community and local level. When viewed as an infrastructure, this adaptive network of modules has the capacity to develop informal food economies within urban areas. By combining both the wisdom of crowds with the technical precision of modern-day sensing technology, a food system can emerge which responds to user growing needs and preferences while growing the urban landscape in new and innovative ways. Thank you for your interest in my project. If you have any other questions, please feel free to email me at evanj1@iastate.edu.